on one hand, I think a lot of folks are building pretty useful stuff around AI, ML. On the other hand, it's also very important to find ways to optimize this, right? Because on top of cloud costs, which a lot of our startups are building on top of the 3, 4 big clouds, there's also additional costs around running AI ML. So how do you kind of factor that in? How do you optimize that? And that's a pretty interesting topic I'm sure folks are pretty interested in. Why don't we just kind of start with the topic that I'm sure, just given Meta is here, open versus closed, and how would that play a role in optimizing your AI infrastructure? Maybe we start with Yogesh and go the other way.
So open versus closed, right? One of the interesting things that we see happening in the industry right now is this interesting push that we see from the closed models to the open source models, right? And there are many different reasons that we see customers having. Oftentimes, privacy is one of the reasons why they do that, right? People don't want to send their data to other providers. Then there's flexibility, because then when you have your own open source models, you have your own infrastructure, and then you have different ways of slicing and dicing the infrastructure and all of that. But especially when you start thinking about that as a factor when it comes to like the flexibility, that's when you start getting into all these issues around like, then how do I build my infrastructure, and how do I get the most out of my infrastructure, and where do I procure it from, and all that kind of things, right? And so that's where we start seeing very interesting sort of challenges emerge right now.
Yeah, and maybe for Yangqing, like how does that, from an optimization standpoint, right? Once my application becomes successful, what are the implications on open versus closed from a strategy standpoint?
So I think, in general, basically in this AI world, this is probably the last few years that closed source models have been kind of like dominating. And in the old days, I mean, in AlexNet and things like that, it's always the open source models and also the open source runtimes and frameworks and things like that that are dominating the market. I think the closed source model are doing really great, mainly because there is the data advantage, the computation power advantage. But I think, if we believe that data is actually one key factor for all those AI models, we would probably tend to believe that the model architectures, the training approaches, and the computation power and things like that would probably very quickly become commoditized anyway. And then who's basically having really a good amount of vertical data is going to be able to train using open source technology and tools and knowledge to basically train their vertical models that are going to be like much better than a general purpose, really great closed source model. So I think for general chit chat and like general knowledge and things like that, kind of similar to Google, I mean, ChatGPT is probably going to be like the most popular tool for us to just like do our daily life with, right? But for vertical areas, and especially places where like, say healthcare, like medicine and things like that, legal and things like that, open source models with custom data and fine-tuned is probably the way to go.
Makes sense. And you guys might have heard of Llama. Jin, obviously you kind of led the build out of Meta's AI infrastructure, and I think it's the biggest cluster, one of the biggest GPU cluster out there. What are some of the key lessons or takeaways for the audience?
I think a couple of things that's been super surprising for myself. One is just, the sheer size, right? I think Bosco earlier in their panel was talking about the speed of GPT adoption. This reminds me my first, related to supercluster kind of project is called RSC, Research Supercluster. That is public information available on Meta's website. This was announced January of 2022. I started working on that project in 2019. And take a guess, given we're late in the session and all that, how many GPUs was it at the time of announcement? Just shout out a number. January of 2022, what was that? 10,000. It was actually 6,000. We did get to 16,000 by mid-year, right? However, in a year, 2023, we get to 24,000 clusters, not only one, but two. And we did the two with two different network architectures. not by choice, but reason of learning, right? So we did one with NVIDIA InfiniBand, and we did one with Rocky. So if you think about the speed and think about how all the AI technology has been adopted out there, it truly drives a very exciting time to say, wow, the AI infrastructure is actually super, super important in our ecosystem today.
Yeah, makes sense. And I do a good segue to my next question, which is procurement, getting GPUs. And I want to hear your perspective, but also Yangqing and Yogesh's perspective from a startup standpoint. What do you see from a strategy or challenge standpoint from just procuring GPUs?
Yeah, procurement is certainly a challenge, I think, for everyone. Many of us are familiar in manufacturing optimization just in time. I would say prior to COVID, prior to this huge GPU demand here, Meta was very much just in time. We were looking for efficiency, right? I have to say we since changed our procurement strategy significantly in order to adapt to the situation, the shortage, the supply chain challenge, the COVID pandemic, all of that. On top of that, most recently in April, we announced our own customized chips. So these are all the activities that we're attempting to, but I'd love to hear from Yangqing and Yogesh as well.
Yeah, maybe I can add on a bit to that. So I kind of want to basically talk about something that's different from GPUs. So 3 years ago, there was COVID. And if you go to Costco, there was one kind of thing that's in a huge shortage. Today, we probably forgot about that. That was toilet paper, right? I mean, there's a huge shortage of toilet paper because people were like, well, for some reason, they were like, COVID leads to diarrhea or things like that. It's like stockpiled, right? And well, if you bought toilet paper, lucky you. And if you look at the consumption of toilet paper, it's not that high. It's just, it's there to sit in your house, right? Today, we see very similar situations when we look at the procurement and the usage, which is something that not too many people talk about. But back in Alibaba Cloud Instance, we observed that people are frantically trying to get their hands on GPUs. But at the same time, if you look at the GPUs that got bought and were actually in people's accounts, cluster, data centers and things like that, utilization is not as high as we would expect them to be. Which basically means that at some point, people will be looking at their stockpile and basically start thinking about, well, how can we actually recover some values out of those, right? And so I think right now, procurement and GPU availability is probably something that's a little bit short term. My prediction is that within the next 6 months or so, the market will become much more fluid, especially because in addition to the conventional cloud and also the big GPU cloud providers like Lambda Labs and CoreWeave and folks like that, there are also a lot of small scale or medium scale data centers who can actually host GPUs of a couple thousand. They won't be able to deal with like the 10,000. Power doesn't allow it. But those kind of availability is actually perfectly well for inference and for productization and things like that. So I don't think it's going to be like lasting too long, this kind of shortage, which is actually good for the industry.
No, yeah. Utilization is definitely a big problem, right? I have seen utilization numbers as low as like 15%, 20%. That means you buy like this expensive, very expensive hardware, and 80% of the time it's just sitting there doing nothing, right? Which is bad. But then there's also taking that and extending that same idea, right? There's also this problem of mismatch of what you have versus what you need. Like, we see many customers who are sitting on a capacity of hardware, whether it's GPU or other things, and they want to be able to run those workloads that they don't believe they can run on the things that they have. And it's interesting, it was really funny. We came across this incident where we saw a customer talking to NVIDIA asking for a buyback program. They were like, hey, can you buy back the GPUs that you have and give me the new ones, right? And of course, that was a joke, but then that joke was built around a kernel of truth, right? They were actually looking for saying, hey, can you give me this new generation of hardware and take my old generation of hardware back? Because I don't think I can run these modern workloads on the infrastructure that I do have. But then therein lies the problem that people often don't realize, that it's possible for you to be able to use what you have for many different things. It's just that it's not just the hardware, but there is so many other things that go in between the hardware and your workload that you have to be able to kind of solve that puzzle.
Yeah, that makes a lot of sense. Maybe a good segue into utilization, resource, and whatnot. Yangqing, maybe from your experience, what are some of the rule of thumbs? If I'm building a new AI application or start a new AI native company, like what are some rule of thumbs when I think about the types of hardware, the types of providers I want to work with? How should I approach that?
Right. I think basically the two major use cases are basically training and inference, right? For training, you probably want to do a little bit more careful budgeting. You probably want to start with smaller scale training experiments and things like that. Make sure that you can actually launch a large training job and having a higher kind of guarantee that it's going to be succeeding, right? And then basically right now, this whole market actually rewards predictability. If you can basically say in 2 months, I'm going to be using 1,000 GPUs, basically do training for another 4 months or so, then it's easier for the suppliers, many suppliers in this market, to actually prepare things and get things going through and things like that. If you want to basically say, hey, I want to have like 1,000 GPUs tomorrow, and I'm going to be maybe using it for a month, maybe using it for 3 months, this whole supply chain gets a little bit screwed up. That's one thing. And then basically there's the inference part. Inference part, I think it's more fluid in the sense that you probably don't really want to use huge, terribly large AI models or LLM models. And you can probably use for some specific tasks even 7 billion or 13 billion parameters, which we found to be a sweet spot for quite a lot of vertical areas. If you wanted to basically do use LLMs as a much higher accuracy sentiment analysis or customer conversion analysis and things like that, 7B, 13B models work perfectly. That means basically these kind of models could be done on a smaller scale, like A10 or L4 kind of GPUs, the supply of which is actually much more fluid and also much more abundant. So I think basically categorizing things and having more predictability would help quite a bit in this market.
Makes sense. Anything to add here, Yogesh? Utilization, different resources, picking, routing the workloads?
So taking the same idea of, you think about utilization, capacity matching, and all of that, right? The idea there is basically, what are the needs, specific needs of your workloads, and what are the things that you have available, and can you get those things to match, right? And so many times we see people chasing this atrocious numbers that we have to bring down the latency to whatever, like we had a customer who were like, oh, we need to have the latency below 400 milliseconds or something. But we're like, why? What is it that you're trying to do? Do you really need that, right? And so it's not the question of trying to chase the specific numbers on whether it's latency, whether it's throughput, or whether it's something else, right? I think what really matters is to try and figure out what it is that you exactly need for your use case, and trying to figure out how to get your infrastructure to match with that, right? Because performance is not a binary thing. It's somewhere on the spectrum, right? Take, for example, if you are trying to send queries to your LLM and waiting for the response. Do you want the first response to come fast, or do you want the whole answer to come fast? And those are two completely different things, right? And so you have to keep all those things in mind when you're trying to choose your parameters and then design your solution around that. And when you do that, what you may realize that there's a lot of new possibilities that open up that you haven't considered before.
I just want to throw one real number example in that. So basically, assuming you want an LLM that's basically having a response time of 100 milliseconds and throwing out tokens at 600 tokens per second, which is really real time, versus if you can relax the requirement, basically saying, I'm actually fine waiting for a minute, and then the model is equally quality, high quality and things like that. I just don't want that fast speed. These two, the pricing could be 100 times different. Yeah. This one is 100 more expensive, like literally 100 times more expensive. So carefully kind of looking at the need is definitely very helpful.
Can I add a little bit?
Please do. Yeah.
So besides, the cost and tighten up the requirements, which is we all needed to do, right? I also think something else I would consider is the workload characteristics. For example, at Meta, if we're doing ranking recommendation, that workload pattern and therefore the compute storage GPU consumption is very different from some other workloads, right? GenAI, what are the things we could do offline? What are the things we have to do online? What about the supporting services such as storage? Where are you going to log it, right? So these, are sort of the smaller things out in addition to the two big bucket of training and inference. But in my learning, I find those sometimes are exactly the gotcha. So when you make decisions, don't forget about those. You have to look at this holistically for your workloads.
Yeah, Jim, maybe on this topic, I do want to talk a bit about potential alternatives to NVIDIA. You guys are building a new chip or customer chip. What was the consideration in terms of, what do you use, say, a certain chip for, right? Like there are obviously other alternative providers out there as well. What are some of the key things, when you design those chips or when you deploy those chips in terms of matching workloads or deployment or scale those clusters?
I'll share two, and then maybe folks can add on here, right? Number one, obviously, is you want to have multi-source, right? Given the scale we're in, relying on any single one is going to be too risky. So for that sense, that's the main consideration of let's do our own, but also let's look at the general purpose GPU that's available in the marketplace, which we're a big user of NVIDIA right now. So that's the first one. The second thing is when you look at ROI, you also need to look at ROI from a near-term and long-term perspective, right? I was intrigued early on when Jason talked about the near-term objective versus the long-term, because it's so hard in technology world when you try to compare apple to apple. It almost never is possible, right? So for example, when we do our custom chips, we tune based on the workload. And that is why these work better, because we know our internal stuff. This is the reason why I chose to go to Meta, because I can talk to my customer with design details directly, right? Infra, user right there. But then it does not necessarily work for, as broadly for general purpose. So there's the pros and cons. On the flip side, right, if you think about inference versus training, I could do two completely different design. Again, optimized for both. But then there's not only the upfront research cost, but also the upkeeping, right? So do I do one and accommodate a little bit of a model role that may not be perfectly optimized, or do we do two, right? So basically, there's a lot of what-if calculation, similar to make versus buy here.
Makes sense.
I can chime in from a perspective of the small to medium kind of companies who are not going to be doing our own chips. So there are two use cases that we often look at, right? One is basically public APIs, and second is basically our own models. For public APIs, my opinion is basically to get whatever kind of suppliers out there that are actually providing the compatible APIs. So if I want to do Llama, for example, there are a bunch of alternative hardware vendors like, say, Seminova or Grok, who are doing brilliant high-speed inference solutions. If I'm just doing APIs, which is exchangeable, I'll just be happily using those as long as the price is right. We don't care too much about their internal cost. When it comes to our own models, it becomes more interesting because the hardware cost is very easily observable, but there's also the software cost. I would probably discount, as a small and medium kind of company, I would probably discount the usability of most of the chips out there, mainly because CUDA has been such a great software library. Being an AI framework writer myself, we've already built more than 20 years of AI software on top of NVIDIA CUDA. And it is really difficult for a small company for me to migrate that whole software toolchain to a different ecosystem. In this kind of market, I think the only, I wouldn't say the only, that's a little bit too extreme. One of the really potential competitor is basically AMD. So AMD starting from, I think, 2016 or 2017, they started a project called ROCm, ROCm. And over the years, one of my co-founders was actually working with AMD to making PyTorch run over there. And what I can share is back then there was quite a lot of cursing going on in the collaboration. But 8 years passed. I think AMD has done a brilliant job making ROCm almost compatible. I wouldn't say 100%, almost compatible with NVIDIA chip. Performance is arguably, dependent on the workload you look at, a little bit higher or lower, things like that. But it is in a usable kind of fashion. So if you're looking for alternatives, that's definitely one direction that you can look at.
So before I joined Sentinel and before I joined Meta, I worked at NVIDIA. And so I'm still holding on to some of my stock options, so I'm going to say no.
Let's go.
NVIDIA is the only game in town. No, but jokes apart, I think in the long run, yes, we will see a lot of the other alternatives come up that will eventually be successful. But when it comes to the reality on the ground, I think we still see that most of the traction is today around like the NVIDIA offerings, and that's just a fact. And there's a couple of different reasons, right? One thing is basically it's hard to make general purpose chips, right? Like for example, Google has been trying to make TPUs into an inference thing. It hasn't, right? It's a great product for training, but for inferencing on TPUs, I still don't see any customers running the inferencing jobs on TPUs. And when it comes to like other specific chips and whether it's AMD and all of that, right? It's the ecosystem that is extremely hard, that piece. It's not just the chips, but trying to get all these other pieces around it, right? And actually working with it. That's where the things start to collapse, right? By the time, because you build out your stack and it starts to work with your alternative solutions, some of the other pieces move. You have a new library version coming out, and you have new PyTorch coming out or something. And then, again, you have to like go back to square one to figure that out, right? And people don't want to spend a lot of time on that. So for now, I can imagine NVIDIA still seeing a lot more traction in the immediate term, but hopefully in the longer run, we'll have more alternatives and more options available out there.
Makes sense. Cool. This has been a great panel. I do want to end on sort of your prediction and your outlook on the future of hardware or GPU clusters or cloud. There are predictions out there saying, hey, if we scale to 25 million chips, we're going to run out of energy. I've definitely learned a lot more about cooling systems over the past 12 months now that this has become such a big topic. Yogesh, maybe I'll start with you. Just any predictions top of mind, as you look forward the next, let's say not 12 to 18 months, but 3 to 5 years? What's exciting?
So what's exciting is that I think we are going to start seeing the cost of running models dropping slowly, right? Because we are talking about utilization, for example. We're going to have a lot more solutions out there that are going to help you get the most out of the infrastructure that you have and all of that. But at the same time, your models are going to continue getting bigger, right? Right now, we are at billions of parameters. You're going to have models with trillions of parameters and all of that. And so by the time we have figured this thing out, you're going to have a new challenge where, again, you're going to have to figure out like how to bring down the cost. So I think that we'll keep seeing this cost parameter going up and down, like swinging back and forth, until we finally find a rhythm where it actually makes sense.
Do you have a crystal ball right now? Like, do you know what the steady state is? When does that happen?
Who knows?
Right. So one thing that really excites me is I believe that right now this is the first time in the last 20 years where the fundamental cloud infrastructure has been challenged. In the past, there was basically two camps of compute or two camps of IT infrastructure that's competing with each other. One is basically HPCs or scientific computations, all those national labs and things like that, right? And then when internet came out, there's the modern cloud, basically, like just killing HPC. And then AI came out, and people are like, I want Slurm. Slurm is a really decade-old software piece that basically runs HPC clusters. And then what we are seeing is that AI workloads is much more similar to all those HPC scientific computation rather than cloud. And so what we are seeing today is actually the merge of these two by having all those GPUs connected in a high performance computation kind of pattern, but on top, replacing the decade-old software with modern cloud-native kind of infrastructure. Me being in Alibaba Cloud in the past, we see cloud providers being definitely like very much like disrupted and rethinking how they could build next generations. And in so doing, I think there could be quite a lot of like open standards or open technology. We mentioned an infinite versus Rocky. Arguably, Rocky is actually a much more scalable solution if you want to go to millions of chips. Those kind of things are still a relatively dark knowledge, mainly because software iterates and shares more easily with GitHub. Hardware shares a little bit more difficult. I mean, Facebook has the OCP, Open Compute Project, and I definitely hope that with all those kind of big, like huge consumptions of AI and computation power, then we could have more open standard and open designs and in the hardware land as well.
My excitement is very much related to what Yangqing was talking about, right? Infrastructure is now the prime space for being challenged, getting innovation in, versus traditionally IT system infra is this back room with the worst kind of decor, and nobody really think it's going to do anything. Besides open source, like we all talked about, right? Besides OCP, there's also PyTorch. Yangqing, you wrote Cafe yourself. There's just tons of great resources out there for GenAI, and get it further piped into every industry and every use cases. I also think it's going to significantly challenge our traditional thinking of problem solving. Like early on, I talked about different workloads, right? Right now, for my world, besides worry about server capacity and network capacity, the word of fungibility is also having a brand new meaning that I wasn't thinking about, honestly, even 5 years ago, right? How is it possible that I would think about making this set of network plus server capacity fungible between GenAI versus ads? Very different workload here. Where do I find the place to hide these supporting servers, have them disappear when I don't need them and have them show up when it's needed, right? And trying to do that at the scale of a few million servers is indeed something pretty exciting. So, people are very concerned about all sorts of things related to AI. I'm excited. I think we will figure out the ways to get these moving forward and get these to do good for our society.
Sounds like we're going to see more open source from Meta.
You can see this coming one after another.
With that being said, I think we're just wrapping up here.
Thank you for having us here.